So now we will see what is that bits. The phenomenon, obviously in case of bits, we have to produce the two sources of there. So the two sources having the different frequency, when they overlap with each other, so in that case you can hear the bits. So that is a phenomenon of regular, that is a rise and fall in the intensity of sound. You can say that when the two waves of nearly equal frequencies traveling along the same line and in the same direction, so when they superimposed on each other, so at some point you will get the maximum intensity, at other point you will get the minimum intensity. So that is what we called it as nothing but your bits. Yeah, so if you see that in the case of your orchestra or some concert, yeah, so initially they just keep their instruments, all the instruments, so in proper alignment, so it will take some time and then they will just produce the beats. Yeah, so that is one of the example for those your bits. Now based on that we have to study the next one, a very important, that is a Doppler effect. Yeah, so what is that Doppler effect? So in case of Doppler effect, so the frequency that heard by the observer is different than that of your frequency emitted by the source when the source is either moving towards the observer or when he is moving away from the observer. So let's say in general case, yeah, so there are two cases which we have to study over here. So it might be, you can say, I will just write it down, this one. So this one, that is a f dash is equals to v plus or minus v naught, and this v minus plus, that is vs, and this is f. So where v is equals to velocity of sound. Yeah, so this one you can say that is a velocity of sound. V naught is the velocity of observer, Vs is the velocity of source. Yeah, so that is the formula which has been given over here. So the source is moving towards the observer. Yeah, so let's say the source is now the moving towards the observer. Yeah, so this is nothing but the source and the observer is standing over here. So what is the change in that, or how you will write it down? So definitely in that case, for this case, obviously this is v plus v naught. Yeah, again you can write it down v minus vs into f. Now again based on that your velocity of observer, yeah, you have to just put that value over there, and since this source is approaching, so this value will get reduced and this frequency is going to increase over here. So that is how you can just write it down for the first case where the source is moving towards the observer for this particular case over here. Now in the next case again the same thing. So when the source is moving, that is away from the observer. Yeah, so definitely you might have seen that the railway engine which is approaching towards a junction. Yeah, you are just standing on that junction, the railway is coming, so whatever frequency that has been emitted by that your source, so and the one which heard by you, obviously there is an increase in the frequency. So that is the same case when the source is moving away, the frequency heard by you is nothing but less. Yeah, so again that is how we can write it down, v minus v naught if the observer is also moving. Yeah, and this is v plus vs into f. F is the original source of your original frequency of the source. So in that case, so this is v minus v naught upon v plus vs. So that is how we are going to write it down, the frequency. So that is nothing but the apparent frequency. So the apparent frequency heard by that your observer is given by this formula in case of your Doppler effect. So that is what we have seen for this case of your Doppler effect over here.